And just I forgot to mention as we started as well, just to let everyone know, we are going to record the session because then we'll take the 2 sessions and upload those to YouTube for use later. So not just about the information here. And I said earlier as well, one of the things we're trying to do with this user group, which most of them should be, is not just about one person sort of standing here and saying, hey, I've got all the answers. This is about a community of people who are using a product who can learn from each other. And so tied in with that, there's a couple of things. One, that's why it's great for us to be meeting in person, because it's the time beforehand, it's the time between the sessions, it's the time after the sessions where you can get to know each other, talk about some of the problems and what you've solved, and build those networking relationships that really make a user group excel in terms of that. So that's why we want to put the content up online later for those who can't necessarily make the sessions, but we want to encourage people to come along. So that's why when we haven't so much distributed the Teams link far and wide. We do have a number of people on Teams today, but the intent, unless we've got a good reason to move away from that, I think is going to try to be to get people together for that and then share the information afterwards. And so that's why we're going to record the sessions and go from there. And so on that basis of kind of saying it's about people sharing, the other thing is what we'd love for people to do is go to the meetup page. There's a link to a form there. If you've got an idea of a topic, preferably one that you're keen to present, but if you're hesitant to present, I'm more than happy to work with you to help you shape that, craft that, and give you the opportunity to do that. Or at worst, if you've got great ideas for topics of what you'd like to see covered, we can see if we can find people who are willing to cover those topics as part of a presentation or similar from there. So if you've got those ideas, we'd love to have those coming through. From there, I'll send that link out at the end as well through Meetup, just to remind everybody as well. But yeah, we'd love that feedback so we've got a good round of sessions. In the end, the last thing you probably want is to hear the same people again and again and again from there. So let's get some variety, let's get some diversity into those topics. So just as a starting point, so we all kind of get to know each other a little bit, just sort of around the room, how many here are from a non-technical role? There are many from a non-technical role, with a few non-technical. I figured we wouldn't have a lot of them. So assuming that everyone else is probably from a technical role, is there anyone here who's not going to put their hand up no matter what I ask? And so from the technical side, how many are developers? Your day-to-day work is development code writing. From the group, I can see most of that. What about from security? Focusing then on anything there? Yeah, a few there. And from an infrastructure perspective? I mean, I myself am more of an infrastructure person. Or any other sort of areas that people are working in that I've kind of missed in those?
Dynamics.
Automation.
Automations?
Marketing automation. Dynamics.
Marketing. Yep. Nice. And that gives us this idea that it's a broad group of people who are all using this one tool to achieve a whole lot of different outcomes. And that's where, again, that diversity of topics and presenters is going to be fantastic, because we can all learn how different parts of the business need to use the tool. And then as we're shaping areas in our work, we can make life better for everybody as we work through. And then just sort of one more question. We had a brief discussion as some of the people were coming in about age of people's GitHub accounts, but I want to sort of talk more about it from an experience. Who would say they're sort of an advanced GitHub user? No, nobody's prepared to put their hand up. They think they might be shoulder tapped for a presentation. What about at an intermediate level? Probably a few of those, yeah. What about from a beginner level? Yep, that's cool. And what about those who have no idea what this thing called GitHub is, but just came for the pizza? So I'm sure there's a few people.
There was a few hands, mostly from Microsoft.
and Will, one of the organisers. So yeah, I don't know. That's how these things go. So again, it's great to have a good, diverse group of people coming along in terms of that, and that's exciting because I think there's a lot that we can learn from each other as we go through. So I'm going to jump into my session, the first session up today, and then Daniel will jump in after a wee break and go through the second session. Tonight, I want to talk about running self-hosted GitHub Action Runners for free. Now, there's always going to be a catch, isn't there? And we'll come to the catch as we go through. So as I've been introduced, my name's Jerome. I'm a lead platform engineer with Mantel Group. I'm based, as I said, down in Christchurch, but do travel around a little bit. Relatively new in at Mantel Group, worked for a number of places, consulting for a long period of time. And then I looked up on the basis of somebody's comment how old my GitHub account is. And it's 13 years old. Now, I will admit there's almost nothing in the first decade, apart from the odd issue being logged. It's only in the last few years that I've really actively used it, but that gives an idea of how I've been kicking around. There's a link, the details there of my GitHub profile that links out to my blog, my LinkedIn, and that if you do want to reach out and keep in touch and follow the sorts of things that I'm doing on the way through. Just as a brief introduction of Mantel Group, because I suspect it's a name that's not familiar to the majority of people. We're an Australian and New Zealand company. Started in Australia was about 8 or 9 years ago. Grown to around 850 employees. We're moving a lot into New Zealand more recently, particularly in the Azure space recently, but we cover data, AI, we do AWS, Azure, GCP, sort of a full suite consulting firm. And please don't berate me for the location of Auckland and Queenstown on the slide. I have told marketing that Auckland is not in Napier and that Queenstown is not in Dunedin, but the slide has yet to be updated. So this is what you get working with Australians sometimes. So as we come into sort of the meat of what I want to talk about, who is familiar with GitHub Actions? So obviously, yeah, a lot of the developers are probably quite familiar with it. GitHub Actions is GitHub's workflow engine. So what that talks about in terms of some ideas of products, if you've used Azure DevOps, that's pipelines. If you've used GitLab, I think they call them pipelines as well. But then you've got your broader workflow engines, things like an Octopus deploy, an Argo workflows, a Jenkins. GitHub Actions plays in that same kind of space with a few caveats. The key thing is it's driven by GitHub repository events. And so the key point about that is it's designed to work closely with the code that you're committing into GitHub and actions that are occurring within GitHub. What that means is when we when we create a workflow, when we design it, we say, what action do we want it to be triggered from? Common one, and I'm sure the developers are familiar with this, is I create a pull request. We get a whole lot of workflows run in the background. They go and do all that necessary thing to increase our code quality as we run through. They'll do the linting. They'll run a build to make sure it works. They'll kick off tests to make sure that the code that we've built is actually able to function. And once all of those tests are complete, then we're ready to say, yes, this pull request can be merged. And that's really useful. The problem becomes, how do we connect those workers? How do we connect that run with on-premises infrastructure or our own private data if we need those kinds of connections? And so we've got 3 ways that GitHub support for running those workflows. The most common way that people I'm sure are familiar with is using GitHub managed runners. And so these are the ones that GitHub have on tap for you. If you specify in your workflow that this needs to run on a Linux box, by default, it's going to fire up on a GitHub managed runner. And that's great if you're running an open source project, because Microsoft doesn't charge you anything for that. But if you're running private projects, if you're in an organization, and if you have private repositories, GitHub limits the number of minutes that you can run unless you pay more money. So there's a cost involved to using those runners. And that's okay, because compute costs money to run. The biggest problem with the GitHub managed runners is that they live in the public internet. And so if I need to expose a private data source, or if I need to expose a private API source for my tests to run against, for example, or if I need to push my code to a private code repository, what we'll then get is what we then run into a problem of we now need to open up public internet access. Now, I have been made aware recently that there is a preview or a feature where we can now bring those GitHub VMs and run them inside a virtual network in Azure. That solves most of that problem, and so is a great solution. But there are other times where we actually need to customize the image, because not every time does the default GitHub VM have the right tooling that we need. Maybe we need a specific version of a tool, and while we could install it on the way past, that increases the length of our code runs. And so the next option is to move on to a self-managed VM. And that has all the benefits of your own virtual machine that you control, along with all the downsides. The biggest one being you now have to feed and water this virtual machine because it's a pet. You have to get the agent installed. You have to keep the agent updated. You have to update the operating system. If a new package version comes out, you need to upgrade the package version. And so this can take a lot of time, particularly for a fleet of VMs. How are you going to manage that? And there are ways through scale sets and so forth to do that. But that comes to one of the other challenges we run into, we'll talk about later. The third one, and this is Microsoft's GitHub scalable solution that they've introduced. They actually started the Actions Running controller and then purchased an open source project to fold into their runner controller. What this involves is standing up a Kubernetes environment. So again, now we have not just virtual machines, but we've got a whole Kubernetes environment that we have to maintain. And again, it gives us flexibility. It means that we can now build containers to run our workflows in, and those containers could have only the tooling that's needed for a particular workflow, but we've got to maintain a whole Kubernetes infrastructure. And for a larger org, or if you're using a lot of actions, that makes a lot of sense. But for a smaller org, there's a lot of overhead there that doesn't necessarily make sense for a smaller org or an infrequent use of actions. And that's where we bring into play a service in Azure called Container Apps. Now, Container Apps is probably not to go too far on an Azure tangent, because this is a GitHub meetup, but Azure Container Apps is probably one of my favorite Azure services, and it doesn't really have an equivalent across any of the cloud platforms. There are similarities, for example, with ECS in AWS, but Azure Container Apps is a serverless container platform based upon Kubernetes. And what that means is that you're able to do most of what you could do in a Kubernetes infrastructure without having to maintain it. So you get scale to zero support natively out of the box. And the biggest one is you get the full suite of the KEDA, the Kubernetes event-driven autoscalers available to you out of the box. And where this makes sense is that GitHub Actions has a KEDA scale. And so what we can do is we can hook up a container app environment that scales to zero, doesn't cost us anything to run the majority of the time, lives completely inside our virtual network, so we have full control over ingress and egress traffic from that environment. And at a time where we've triggered a workflow to run, the KEDA scaler will fetch those details from GitHub, spin up enough pods to run those workloads for us of the right type based on the configuration, execute those, and then those pods will shut down at the end, and then we've got nothing running again. So that gives us a very quick response with the scaler. It gives us no running cost the majority of the time, and we're only paying for what we use. So it's a great way of doing it, and from a cost perspective is very comparable to running a GitHub managed runner. But as I said, there's always a catch. What's the catch with something like this? Well, the first is that, okay, I sold this as running GitHub Action Runners for free. And that's right, up to about 50 hours of runtime. So Container Apps in Azure has a free threshold, which equates to about 50 hours for a single vPCU and 2 gig of RAM on a container. So if you've got a small enough set of workloads, you could run that. If you need to go larger, obviously it eats into that a little bit more quickly. The second challenge we run into with this setup is the API limits at GitHub for the polling. So I mentioned that the Kita scaler will go and fetch a list of outstanding workflows. The problem we run into is that we can only do 15,000 requests an hour with a GitHub application. Now, that seems like a lot, but if you had 100 repositories that were being checked and 10 of those had workflows to execute, that's 110 requests for one Kita poll. If you're polling every 30 seconds, you're running 3.6% of your hourly rate every 30 seconds. So there's not enough time there. We can work around that by splitting out the number of scalers that we use, segregating them into multiple applications. But any of that starts to add complexity, and this is always the challenge. Again, the other way of dealing with that is to spin up a web service that could respond to incoming requests and auto scale in that situation. So there are ways. Probably the biggest catch with doing this is the lack of support for Docker actions. And that's because Container Apps doesn't support running Docker inside a container. So in Kubernetes and on Docker, they have a Docker in Docker functionality, which allows you to play Inception and stack your containers multiple depths. That's not supported inside Container Apps. And so you do have to be careful if you're using actions provided by third parties as to how they run, because there are two supported ways in GitHub Actions to provide a third-party task to run in your workflow. One is by writing it in pure JavaScript. The other is providing a Docker container. And a lot of tooling, and so I said I come from an infrastructure background. One of the tools that I use a lot is Terraform Docs. It helps generate documentation of Terraform code. The GitHub action for Terraform Docs runs in a Docker container. And so I can't actually use that official action if I'm using a container app to run. You can work around that, but you have to spend a bit of time to do so, and you have to go hunting for workflows and actions that are written in JavaScript. And then, of course, like any solution that you're building yourself and managing yourself, it needs some feeding and watering. So we need to maintain the container image that we're going to run our actions in. Microsoft do provide them as part of the Kubernetes Arc system. However, for some reason, and if anybody happens to know someone who works at GitHub that might be able to take a complaint, the problem with the GitHub runner itself is it requires you to give it either a personal access token, which for those in the security in the background, I can imagine a shuddering at the mention of using a PAT, particularly a long-lived one, to register the runner. You can, but you can't just pass it a GitHub application to do the registration. You actually have to put a script in front of it to get a token that can be passed in as a short-lived token to do the registration. So there's a bit of working to do it, but there's never anything quite for free in the end. And so this is the solution that we come to when we sort of put all this together. So what we've got here on our left-hand side, and I'm just managing to skip ahead, here on the left-hand side, no, I don't want to do that, is our Container Apps environment. So this is where we put it into our network. We set up, in this situation, 2 jobs. And those jobs would have a scaler, which are tied to specific repositories. This is how we get around those API limits, because by splitting our polls across multiple apps, we can now go, right, this one's can do this number of repositories, and so on from there. Every 30, 60, 90 seconds, however long we want to do it, that scaler reaches out, queries GitHub, and says, give me a list of the workflows that are pending for these repositories. How many of them are there? It then goes and scales up a number of containers to actually do that execution. Those runners come up, they register. Once they've registered, they fetch a job, they run the job, they power down, and we don't pay for anything from there. And so now we do get to the exciting part where we actually get to see it in action. And I know I've talked for a long time and the demo will fly by really quickly because in the end it is relatively simple. But what I've got here to look at is a set of workflows that I'm doing some testing on around Terraform automation. As I mentioned, I'm an infrastructure guy. And so this workflow has a number of steps, some of which are chained in dependencies. So we start off with our linting and validation. We run a Terraform format to make sure our code is formatted as it should be. We generate our documentation once we know that the code is valid. And then we generate a plan to see what infrastructure change would happen if we executed this plan. And so if I then run this code from here, what we'll see, or this workflow, is that it's now going to start up. And so we've got 3 pending actions here. If I come across here to my container app, what I can do is refresh from here. And we'll see at the moment, we're in that polling stage. So I've executed it, but we're waiting for a poll to kick off inside the container app to see where we're going. So here's my scalar. We're looking here at GitHub, and this is the details of where we're looking from there and how we're doing it. And so if I come back now to the execution history, we should see that it's now started up 3 containers for me. These are Kubernetes jobs. And as those containers come up, we'll start to see logs available. Those runners will register with GitHub. And so at the moment, we've only got the standard runners available. Again, it takes a little bit of time for all of these registrations to occur. The lag time is about 60 seconds on the way through. So here we have those runners have now come up. They've registered themselves against a runner group. They're populated with the runner tags that have been defined upon that job. And this is where we can set different containers and different configurations to have different configurations. So we might have a build container that has the tooling required for build, another container with the required tooling for testing, and we can pull a container that's optimized for the task that needs to be run from there. We come back here, we can see that those 3 tasks have completed and 2 more are queued. So we come over here and we'll see that those 3 tasks are now succeeded, and they all ran in under 60 seconds. The tasks I've got to run are relatively quick. And if we refresh again, now we've got 2 more. And so these are brand new runners that have never been used. So there's no possibility even at this point of cross-contamination. So if we'd pulled code into the first one and run a build, there's no way that anything from that is left over if we spin up a new container, pull in an artifact, and use that for doing our testing or anything like that. Again, we have a look at our runners, and the tasks have completed, so or are they still pending? So we haven't registered yet. Here we are. The 2 of them have registered. We see our tasks kicking off here. Of course, we wait for the longest one to run because that's the last one to happen. And as I come across here, we can see that the first one will have succeeded while the other one is still running. And as part of that process as well, it also deregisters the runner. So we're not left with an old runner kicking around as well. And so this is now completed, and we're now back to having nothing running in our container apps environment. We're now not paying anything. So we only paid for, in that situation, 5 jobs of around a minute to a minute and a half each. That comes out of our free credit, and this is how we can do at least a level of our runners for no cost. Any questions that flow from that? Anyone like me to sort of cover a little bit more? I know we're just past half past, and so we'll take a break in a couple of minutes, and then Daniel will come and talk about Copilot. But any questions on runners, container apps, and that interaction?
You have done a great job. Thank you.
Another question here. Yep.
Have you tried to set it up on AWS in case?
I haven't looked to set it up. If you were running AWS and EKS, I would just look to use the Actions Runner controller. So that's designed to be running in Kubernetes already. So you could do this 100% in any Kubernetes platform where you've got your key to scaler able to run for you, because that goes out and reaches out and does that polling, spins up the workloads. And with something like Carpenter, which you can use cross-cloud now, but very much is focused on an EKS perspective, that will spin up nodes for you as well under the hood. It'll take a little bit longer to spin up because you're bringing a whole node up potentially and not just a container. That's the advantage of the consumption plan inside container apps, because there's provisioned compute available to you under the hood that you just take action on as you come through. But yes, in terms of EKS, absolutely, you can EKS. You can run Arc and these actions runner and use Actions Runner controller to do this whole thing as well, and keep your costs down by scaling to zero. A question about getting around the Docker limitation. The only way to get around it is to rewrite the actions you might have been relying on into either standard scripts and standard actions, or to go and write JavaScript actions yourself to do the work that's happening inside the Docker ones. It's a limitation of container apps that you can't run Docker in Docker, at least at this stage. If it's something that people want to go into and do more, yes, then you can do that. And yes, Luke, you've found me in the background there where I've got a repo where I've sort of adapted a script I found elsewhere to build up the image to run inside GitHub Actions for that as well.
Another question in the room.
Yeah. So have you tried using a WireGuard and in the cloud create a VPC or VNet with a private subnet and then connect it using a VPN credentials or something like that?
No, I haven't. I'm too lazy to, in the end, is probably the first one. And typically the other side of it is I also tend to work more so on an enterprise scale where I'm dealing with organizations that actually have hard requirements to control all inbound and outbound traffic and have things inside virtual networks. But that's what's exciting me about the ability to put the GitHub managed runners into a virtual network in Azure, is that that's giving us that level of control that we haven't had while having to not also maintain the runner images and everything like that. But once you get beyond a basic level of GitHub Actions, you actually want to start customizing the tooling that you're using and the VM that you're using or the container you're using. Because if you've got to run the same workflow a dozen times a day, and if it takes 60 seconds, say, to download and install your tooling on each run, you're losing a lot of velocity because the tooling's taking so long. And that's the point where automating things and actually having an environment that comes up and already has what you need makes things a lot quicker. But no, to go back to the specific question, no, I haven't used WireGuard. I know that GitHub do advertise it and have documentation on doing it. And it is a good solution if you've got a WireGuard environment that you can connect back into as well. But that still has the same problem. Now you've got something you've got to feed and water living inside your network to maintain that connectivity.
Other questions? No other questions in the room. Any other online? Nice round of applause for Jerome.
Thanks, everybody. It would have been nicer to have been there in person. I look forward to catching up with you guys next time we have one, and to be able to meet you guys in person. So thank you very much for coming along.